Okay, I'm excited to talk about something that could be a game changer in the future of how we interact with our monitoring system. I'm talking about using AI assistants with your monitoring. A couple of months ago, the terms AI agents, RAG, MCP, etc. were kind of background noise to me, but I decided to look into there was so much hype around MCP, and it ended up developing MCP servers and leading to what I'm going to talk about today. If you don't understand what I'm talking about, don't worry. We are going to break it all down during this presentation. It's going to be quite extensive and dynamic, so make yourself comfortable. Sorry in advance, it can be a bit long, but yeah. Okay, here's what we'll cover today. First, I'll explain what MCP is, how exactly it works, and why it matters. Then we'll dive into VictoriaMetrics MCP Server, how to set up it, and what it can do. We'll explore real-world usage examples and scenarios, look at cloud integration, and discuss what's coming next. And a word or two about MCP VictoriaLogs at the end. In general, the presentation will have two main parts. The first one is about how it works in general, and the second one is about how it works with VictoriaMetrics. So let's start from MCP and what exactly is MCP. Why are we only on the third intro slide of the presentation, and this is about the 100th time I've repeated those three letters. The acronym MCP stands for Model Context Protocol. Sounds kind of abstract, but what you should know is that protocol is the main word here. It's an open standard. It's an open standard that enables AI application to connect to and work with external data sources and tools. MCP allows AI models to access real-time information, databases, services, and providing consistent interface to developers for integration with various data sources. The protocol was introduced by company Anthropic. It's a company behind Cloud. It's relatively new. It was introduced about half a year ago, but the adoption was been incredible. Just look at the ecosystem growth. We already have hundreds or maybe thousands of MCP servers available for different services and tools. The community has really embraced this standard because it solves a real problem. I really love this analogy from the MCP documentation. Like think of MCP like USB-C port for AI applications. If you want to learn more about this technology after the presentation, there is no better source of knowledge than the official website of the standard. Well, it's time to find out exactly how it works. I want to demystify this topic for people in observability with explanation of how it works. Importantly, you don't necessarily need to know about all of this to use it, but knowing will help you to use it more efficiently. Let me walk you through how this works in practice. Imagine you have some application with a chat interface. It can be real chat interface, it can be voice-driven interface, it can be even some classic application with buttons with chat interface under the hood. And you have some external services, databases, or tools. For example, let it be some application by VictoriaMetrics. You want to make some request. For example, send message like, hey, tell me something about my metrics. What is your expectations here? Of course, you expect your application to go to external sources, somehow get a bunch of useful information, and simplify, summarize, structurize it for you, and answer your question with the most comprehensive and high quality answer possible. Pretty appropriate expectation these days. And how it can work. Of course, you need LLM for it, but that doesn't answer the question. Before we answer it, let's make sure everyone understands what an LLM is. LLM means large language model. Here's some definition you can read. I don't want to pronounce it. And I want to tell you about main point here. You should distinguish between LLMs and AI services, AI platforms, etc. These terms often mean the same thing in people's mind, and it confuses them. For example, ChatGPT is a service that provides a lot of functionality around LLMs called GPT. I mean, LLM is just very simple API that can predict next letters based on previous ones, and that's it. Everything else you work with in ChatGPT, like UI, chats, web search, different settings in some code, created around LLMs and interaction with LLMs. One important thing I'm trying to say here for the next slide, it's that LLM can only generate text. It can search the web in the web or call any APIs or do anything like that. So let's come back to our scheme and let's see how it worked before MCP. Before MCP, we had to create a lot of tricky code that integrated to the client and works with your external data. This code was specific for certain client, certain external service, and could be even specific for certain LLM. That doesn't sound good because it leads to the M times N problem. It means if we have M clients and N services, we have to create M times N integrations. It's completely unscalable. So let's see how MCP solves this problem. To connect some external service like VictoriaMetrics, you should have some special lightweight application called MCP Server. I've shown you before that there are already a huge number of such servers created for different data sources. And this MCP service provides some unified API. That's why I pointed out earlier that in acronym MCP, the main word is protocol. This means that any MCP server can be interacted within in uniform manner. So your client should somehow be able to interact with MCP servers. All or almost all popular AI clients already know how to do this. They just connect lightweight MCP client libraries in any language and can communicate with MCP servers. This application we call MCP hosts. But what does the interaction mean? What lies behind the protocol there? Okay, let's dive a little bit into this particular part of our scheme. MCP provides JSON RPC-based protocol that declares several entities. The first one called tools. It can be described as some actions that MCP servers can do. It's some executable functionality. From the client's point of view, you can receive a list of tools and execute any tool. That's it. The second one called resources. It's some data to extend context for LLM. From the client's perspective, you can retrieve a list of resources and read the content of resource. And that's it. The third one called prompts. It's some reusable templates for messages to AI. From the client's perspective, you can get a list of prompts and get content with some placeholders. For example, prompts can be common recipes or scenarios that works with this certain MCP server. As resources, MCP server can provide documentation and context to help the AI understand your system. But the main entity here is tools. Tools are powerful primitive in MCP that enable servers to expose executable functionality. Through tools, LLM can interact with external systems, perform computations, and take actions in real world. The simplest analogy to tools is your endpoints for your API. That's why you see the Open API logo here. But the fact that tools is the primary tool that you can associate with your API endpoints means one more very important thing. If your service has an Open API spec, you can very easily to create an MCP server for it. And it's very easy to start interacting with it from the AI assistant. Most MCP servers do nothing more than translate Open API spec into MCP tool-based spec and just do the recall, and that's it. There is no problem for you to generate such MCP server for your service if you have any API spec. There are several tools or resources that I found for that, but I didn't check it. And you can also easily find lots of articles on Medium or other resources, like turn your Open API in MCP server in 5 minutes. But let's come back to our scheme. Perhaps the last thing you should know about here is what kind of transport is used when MCP server and MCP client communicate. But we'll talk about a bit later. Well, that's what we have at the moment. We have MCP host application, we have MCP with MCP client, we have interaction with MCP server, and of course we have LLM and some user that send us his request. The beauty is that the AI doesn't need to know specifics of VictoriaMetrics API here. It just needs to understand which tools to use and when. Of course, we'll forward his request to LLM, right? But it's still not clear how the interaction with MCP server will happen, how we will get and call tools. I mean, we already know that LLM can't do anything like that. So let's take a closer look at what's going on inside the MCP host app. We have requests from user, we have MCP client, MCP server, and LLM. And we know that we need to send requests to the LLM, and we need to somehow figure out if we need to interact with MCP, and if we do, then perform the interaction. How can we do this? Given that we have universal information analyzer and question answer, of course, we can ask LLM what we should do. For example, we can send some query like, hey, LLM, here are some query and list of available tools with their descriptions. Based on this data, tell which of the tools should I use to answer this query. It's not real prompt, it's just demo how it can work. In real life, of course, prompt will be different. For example, we should say about formats and rules, etc. However, we can get list of we should call, and of course, it can be empty. But let's imagine we've got one tool. We have tool with description, and we have parameters of these tools with their types and description. How we can find out values of these parameters for the query? Of course, we should ask LLM again, like, hey, LLM, here are some query and description of the tools and its parameters. Tell us what values I should use for this tool. And now, after the answer, we have everything to call MCP server and get some extra information. But what we should do with this information now? I think it's not hard to guess now. Of course, we'll answer LLM about query from user, but now with provided context from tool. And now LLM can give us a comprehensive answer. Of course, it's simplified approach, but now you can learn new term. Now we have AI agent here. What is an AI agent? AI agents, it's autonomous software tools that perform tasks, make decisions, and interact with the environment intelligently and rationally. They use AI to pursue goals and complete tasks on behalf of users based on real-time feedback and changing conditions. AI agents can work on their own or be a part of bigger system based on the data they process. So here's the magic. Our part inside of the MCP host is also kind of AI agent for working with MCP that can understand your question, determine which tools it needs, call those tools with the right parameters, interpret the results, and provide you with meaningful answer. All of this happens automatically through natural conversation. And now we have the full picture and understand how everything works. And the nice part here, that's not necessarily to know for using it. What we should definitely know that we need an MCP server if you want to integrate our service with something, with AI assistant, and it will work naturally as intended. And that's it. So now we know almost everything what we need about MCP servers in general. Now we can explore MCP VictoriaMetrics. You can find full documentation in project README by the link, but let's take a quick look into key things here. Let's start from installing. Installation is quite straightforward. You have several options for installing MCP VictoriaMetrics. The first one is just use Docker image. That's it. If you have Go installed on your machine, you can use the following command to install from Go package. Of course, you can clone repository and build from source manually with Docker or with cooling CLI. And you can just grab pre-built binary files for all popular operating system and processor architectures. And in addition, you can find in README other ways for installing the MCP server. So now we have executable binary file. What we should do with that next? You need to choose the client. Where you will interact with your VictoriaMetrics instance. There are a lot of clients. Moreover, I think you already have a couple. For example, popular editors like Visual Studio Code, IDEs from JetBrains, that already have embedded MCP clients inside. Vim also have plugins for integration with MCP clients. If you use terminal called Warp, it's also have MCP clients inside. There are several lists of MCP clients in web. You can see a couple of on the slide, and you can find many different types of MCP servers by the links. It can be chats, editors, terminals, CLIs, chatbots, automation platforms, debugging and testing tools, AI agents, smart home applications, etc., etc. Here are several ones that you can already know about. So I'm gonna suggest, I'm not gonna suggest some best client because it depends on your tastes, needs, requirements, etc. I'm just going to tell you how to set up MCP VictoriaMetrics in your client. The MCP server supports several running mods. By default, it runs in stdio mode. I'll tell you about mods very soon, but just now I'll tell you about running in this default mode because it's easiest way to start. So for setup in MCP in your client, you should just use the several things. The first one, you need to specify some human readable name. It's just for you. You will see this name in the UI, and if you have several MCP servers of one type, you can use this name in your prompts to say the LLM that you want to use the specific one. The second thing, you should specify paths to command in your system for running MCP server. It's binary file that we just downloaded on previous slides. In some cases, you will need to specify command line arguments for those binary files. And MCP server parameterization takes place through environment variables. There are 4 things that you should specify to run the MCP server. Let's see how it looks in practice. Here's configuration example for cloud desktop. It's just JSON file with MCP server objects. And here you can see the name of MCP server in JSON key of this object. The next one that you can see there is the path of command to run the MCP server. Command line arguments for this command can be also specified in args attribute, but I didn't show it there. And the last one thing is env attribute with parameters of the MCP server. So why did I start by listing the things you need to specify rather than just give you configurations for popular clients? Because there are hundreds of such clients. Here is an example for Visual Studio Code. It has a bit different format, but the same things you need to specify. Here is config for cursor. It has the same format as Cloud. Configuration for Z editor, a bit different, but the same parameters. For all IDEs from JetBrains like Golang, PyCharm, WebStorm, etc., parameters are the same. I just wanted to say that regardless of the client format, which you can read about in the documentation, you only need to understand the meaning of parameters and specify them to configure the MCP server in your client. What if I want to use Docker instead of local binary? So you need to replace command with Docker and add arguments section for specifying Docker parameters like on slide. By the way, you can see real working parameters to run your MCP server connected with our public playground. You can just try MCP with these parameters and this should work. After configuring MCP server, you should see the server. You should see the server and its tools in UI. But of course, it depends on your client. More details about configuration parameters you can find in README of the project by the link. We won't discuss them all, but there is one thing I do not to mention. Do you still remember this our scheme? It's time when we have to talk about server modes, aka MCP transports. We discussed what format like JSON RPC, business logic, and entities are behind this arrow. But we didn't discuss how technically MCP client connects to MCP server. I mean, what transport is used there? In current version of Model Context Protocol declares next transports. The std.io transport enables communication through standard input and output streams, like pipes. It's the most common MCP transport, perfect for command line tools, desktop applications, and local integrations. std.io is really good as start for playing with AI systems. I recommend to always start from std.io. It's simple, fast, no network issues, minimal memory and CPU overhead. The next one is called streamable HTTP. This transport uses HTTP post request for client to server communication. And
Alex, we don't see your screen. So I believe you need to reshare it.
Okay.
Add to stage, yeah.
Oh,
okay.
Do you see now?
Yes.
Okay. HTTP posts for client to server and server send events for server to client communication. You should use streamable HTTP when building web-based integrations when you need client-server communication over HTTP. It's the most modern standard transport for MCP, but unfortunately, it's still not supported in some clients. Maybe because it's more complex, like with HTTP, you should think about a lot of stuff like authorization, load balancing, rate limiting, caching sessions, etc., etc. All these things are possible with streamable HTTP, but it's a bit complex. Of course, you've got some overhead in speed and in resource usage comparing to STDIO. The last one called server-side events. This is predecessor of streamable HTTP that was deprecated some time ago. But as I said before, unfortunately, there are some clients that do not support streamable HTTP, but support SSE. That's why this protocol here still supported everywhere, including our server, but I don't recommend to use it if you have other options. So what we have now is transport options between MCP client and server. I'll repeat again, I'd recommend to start from STDIO and move to HTTP only when you are going to use it in production on a regular basis for multiple users. I'm not going to tell in this presentation how to configure network protocols. You can find it in MCP server README, but I had to tell about them in general. And now that we finally know what MCP is, how it works, now that we finally have MCP VictoriaMetrics installed, running and configured, we can start using it and figure out what it can do. So let's explore tools supported in MCP VictoriaMetrics. There are a list of them. I think if you are familiar with VMUI and use it, you should know the most of these tools. Here are some mapping to the VMUI. We can execute instant or range queries, get results such as on table or graph. We can get and draw raw samples with the expert API. We have option for tracing queries in queries. We have separate UI proxied from VM alerts for working with alerts and rules. We have tenant selector, we have button for predefined query, and we have a lot of separate tools which contain a lot of useful information functionality. The only tools which are present here but not covered in VMUI, it's test rules, explain query, and documentation. Functionality of these tools exists only in MCP server or in case of test rules as separate tool. So I will not describe each tool there because literally on the next slides we will practice with all of them. So eventually we are here. We can start using MCP step by step in real scenarios. Let's start from the beginning. We have VictoriaMetrics instance. We are going to use it, but it's multi-tenant cluster. We should say to MCP which tenant we want to use. Let's do it. So we can use natural language like give me the list of available tenants, or we can use which tenants do we have, or other sentences. And the AI assistant should understand us and give good answer about existing tenants. So you can see the screenshot of cloud desktop application on the slide. And I want to show you a lot of chats on the following screens, but it will be a bit different to follow them on screenshots, and it's not look good. And I like nice looking presentation. So starting from this slide, I'm going to show chats like that, but it was real chats. So again, we are asking about existing tenants, and we can see that our assistant hanging in some special block. This block means that we are calling tool from MCP server. After some time, we are getting human readable answer with the list from 4 tenants. And in addition, we can see that one of them is default, and we can see information about format of the tenant. I think this answer is complete enough. But how we can select the tenant as we do it in VMUI? It's easy, since one of the most important capabilities of AI assistants is storing and understanding the context of conversation. We simply ask it to use a specific tenant from that point on, in this case, the default tenant. And that's it. From now on, we are working with the tenant that we selected. Well, it was easy and fast. Of course, this tool is very simple. Let's check the next ones: metrics, labels, label values, and series. Let's check out what we can do with them. We're just going to continue our previous dialogue. Of course, we have lots of metrics. Let's ask what metrics do we have and see how AI Assistant will show us these metrics. Of course, it uses this new tool from MCP Server called metrics. And after that, we got summarized overview of our metrics, which groups of metrics we have with which suffixes. So let's check out of metric group, for instance, argcd. So we are saying, show me argcd metrics. It's using the metrics tool again. And after that, we can see all metrics from argcd sorted by categories. It's not the full message here. It's long enough. Let's check the labels of the first metric, for example. What labels does the argcd app info have? Well, new MCP tool now, series, and we can see all labels grouped by two categories: argcd specific labels and common labels that Kubernetes or metrics collector brings to us. So we need to go deeper. Let's check the values of some of the label. For instance, what values I have for label name of this metric. New MCP tool again, label values. And also note that a few messages later, the AI assistant still understands the context that we are still talking about the argcd app info metric. And it's really good. And there we are. We can see what applications we have in argcd. Of course, in this dialog, we're discovering capabilities, but if we had the end goal of finding out the list of application argcd right away, could we do that faster with one prompt? Of course, we can just say, show me the list of applications in argcd from my metrics, and we'll get the super full answer. And pay attention to a couple of things here. The first one, how I made my request. I've added this from my metrics to help the LLM, and it's important if you ask some abstract questions without terms of specific MCP. And also pay attention to the thought process section here. LLM creates step-by-step plan for answering your question before doing something. The user is asking me to show a list of applications in argcd from their metrics. That means they have a VictoriaMetrics instance that collects metrics, and they want to see argcd application information from those metrics. To do this, I should first look at what metrics are available, if there are argcd-related metrics, then query for argcd application metrics specifically. Sounds like I help LLM to understand how get application list. What if I hadn't added this sentence? In this case, LLM don't know what to do and give you advice about how to get application list with argcd tools. So in abstract queries, you need to help the LLM understand what you mean. We practice a bit with these metadata tools. Time to try alerts and alerting rules. So let's just check current alerts. New MCP tool again. And we can see information about current firing and pending alerts. Of course, for this functionality to work, you need to deploy VMAlert and configure VMAlert proxy URL on your VictoriaMetrics select or single. But I have to be honest and should to tell you about one problem here. If you want to replicate this right now on Playground, you will fail miserably. I took old screenshot from my previous dialogue because right now on Playground we have hundreds of alerts, and Cloud have limit for tool response 1 megabyte. With many other tools, this problem is solvable because they have parameters to narrow down the data sample, and LLM gets an oversized error and does it by itself. It just makes several smaller queries instead of big one. But it doesn't work that way with this API and a couple of others because they don't have those parameters in VictoriaMetrics. I even added, but haven't released yet, on the MCP side filtering by group and alert status. It didn't help as all alerts are in the same group and have the same status. So this problem that still needs to be thought about and solved in the future. But right now we have a problem like that. But for now, let's do something weird. If we had a few alerts and I'm asking you to show me what the query graph looks like in those alerts, when I made this query, I didn't expect something really useful. And when I saw this, I was a little shocked first time because it's not just a visualization, it's the dashboard. The assistant took queries from the current alerts, executed those queries, wrote some React code that visualized those queries and displayed them to me as a dashboard. And I'm going to show you a couple more examples of this feature in the following slides, but not right now. Later I realized that this wasn't just regular behavior of LLM, but a cloud feature that I had enabled when I was fiddling around in the settings. So I'd really recommend to activate this feature if you are going to use cloud with observability tools, because this is an amazing feature. But we have to continue. Let's have a quick look at what kind of alerting rules we have. And here are some alerting rules sorted by categories. I should have talked more about the scenarios here, and in particular the rules testing tool. This is quite a complex topic, and we still have a sort of presentation ahead. So unfortunately, we will skip this topic for now, maybe in the following parts of our meetups. I don't know. Let's move on. We should take a look into active and top queries, but we'll extend this block, and also we'll take a look into query-related tools in this block. Okay, assistant, show me 3 slowest queries. New MCP tool again, and also note wording here. Assistant in his thinking translated slowest queries to the top queries with the biggest average execution duration. It's really great. Well, we can observe our slowest queries with average execution times. Let's work with first one from now on, and now it looks a bit ugly. Let's prettify it. Using new prettify query MCP tool, and now it looks better, formatted and query with even syntax highlighting, but it still looks pretty complicated. I think without specific experience, it's really hard to say what exactly this query does. And it's time to tell you about the feature that exists only in MCP VictoriaMetrics. It doesn't present in VictoriaMetrics itself or in Beam UI. It's a tool called Explain Query. You can see usage example on the screen. We ask an assistant, explain me following query, some rate, VM HTTP request total, with a 5-minute look behind window. And we've got detailed step-by-step explanation with query breakdown and summary with short human readable explanation. But you can say, hey, it's really simple query. Everyone knows how some rate works. Fair enough. Let's come back to our dialog and check out this tool with our big slowest query. So now explain me this query. Of course, I don't want to repeat query text, and I just use context. Assistant call explain query MCP tool, and that's what we have. Short explanation about what this query does, and then step-by-step breakdown from 3 parts with details about each part. First one checks that query free space in file system less than 15%. Second one uses linear regression to predict whether free space will run out within 4 hours. The third one excludes read-only file system from the sample. And then explanation how these three parts work together. I think that's a super complex explanation, so super complete explanation, and how it works. I showed you before simple block that show you call of MCP tool. Of course, it's not just tool call. It has request parameters and response. And depending on your client, you can expand this block and see request params. In this case, it's not so interesting because it's just our query, but you can see the response here. Let's copy this response and take a look into it to demystify this magic. You can see JSON with 4 sections. There are only 3 of them on the screen. It's not just important, but okay. First one called functions info. There is one function here, predict linear, because we used only one in our query. It contains function description and category, rollup, brigade, and etc. All this information is taken from parsed metrics scale documentation. The second one called metrics info. There are 3 metrics, those we used in our query: not file system avail bytes, not file system read only, and not file system size bytes. It contains group or source of metric, description, type like gauge or counter, and some labels. Third one is called syntax tree. It's our query parsed and presented as JSON in form of syntax tree. The largest and the most difficult to read section for humans. And the last one is called types info. It contains meta information about node types in syntax tree. Nothing interesting here. So, and this huge JSON we just give into LLM and saying, hey, here's a bunch of meta information and documentation about the query. Turn it into human readable form, and it does it. It works very well, and we saw the results. An attentive viewer might have wondered, I understand about functions info, syntax tree, and types info, but where did the information about metrics come from? Many of you know that the information is not available from VictoriaMetrics because it doesn't store a metrics metadata. That's still the case for now. That's why I spent some time, honestly a lot of time, to collect static files with metric metadata for other popular tools like Node Exporter, Kube State Metrics, Kube API Server, etc. But there are quite a few of these files now, and it's quite difficult to generate them, but I just wanted to make POC with this, and it works awesome. This works even for metrics that aren't in the database, just a little worse. I hope this can be dropped out and everything will work after implementing this functionality. As far as I know, it's already in progress, and this feature will be really helpful for AI functionality, because right now AI works really well with known metrics because it has some internal knowledge about open source and popular metrics. But if you have your own internal product with some metrics, it can work not good. This issue should improve this situation. Yeah. Let's go next. We already know what our slow query should do, but let's try to understand what's the reason of slowness. Trace this query. Query MCP tool with trace option. And here are some details about execution of this query. How many data selects each part and what's duration, and some summary about possible slowness reasons here. Pretty good, I think. Okay, show me the graph for this query for the last 24 hours. Now query range MCP tool, because we requested query for some range. Hold on. What's going on here? Why query range again? and again and again. Let's read the text. The query returned no results over the past 24 hours, which means no file system met all 3 criteria simultaneously. This is actually good news. Let me create a more informative dashboard, blah, blah, blah. It means AI assistant doesn't found results for this particular query, and it splitted it to 3 parts and executed separately. Yeah, and I think it's a good decision. In the meanwhile, we've got dashboard, and this is how it looks. We can see that all of file systems have more than 90% of free space, and that's why our full query returns empty results. But to be honest, it's not really interesting query and dashboard. That's why I wanted to show you another one, not related to our previous dialog, but still pretty good. But it's query from our public chat. Like, show me CPU utilization on some specific host for the last 2 days. And here is the graph and some text summary. It's like Grafana for humans. I think it's really good thing. Okay, we finished this block. I'll try to speed up a bit. Let's get some metric statistics inside with these tools, and we'll also take debugging tools in this block. Give me the most cardinal metrics. Great, you've got the right tool, TSDB status, and there is a table with metrics ordered by cardinality. Looks great. Which of the metrics are never used? We are seeing that unfortunately all of them are used in queries, but let's see what assistant can say next based on metric stats tool. Okay, he said that metrics with the highest cardinality are already used in queries, but there are metrics that is never used, and some other interesting insights here. Okay, let's ask assistant to create relabeling rule for us and to remove all these unused metrics. Metric stat tool again, and he found the metrics and started to create a labeling rule. And he's doing more for us. He didn't just generate a relabeling rule. He's testing it with the Metrics Reliable Debug MCP tool. That's really awesome. He's running another test and another, and that's it. He created for us relabeling rule, tested it, and gave us some summary about testing. That's how it looks in real dialog, and you can see several different options of correct relabeling rules here, and some test report. I'm really excited about it. And we finished with statistics and debugging tools. We tested only one debugging tool, but I don't think that will be a problem for you to use the rest of them. So we have the last tool. Not only we want to use VM API, but we want to find answer to our questions. Let's just ask any question about VictoriaMetrics. For example, how to write data to VictoriaMetrics Cloud. We are seeing using of new tool documentation and another one, and now assistant prepared some answer for us. And that's how answer looks. It's completely comprehensive answer. That said, it's worth noting that I have web search tool turned off, and this stuff about access token just recently appeared in the docs. And at this point, I should be telling you about RAG systems, but unfortunately that will be definitely not fit in this talk. So many things to tell around all of this. But what you should know that here, MCP server contains all VictoriaMetrics documentation and can search it and provide as context for AI assistant. In addition to documentation, it also contains all our blog posts, because so many really amazing blog posts by Fong, Rikun, and other guys recently. I'd recommend to subscribe our blog because it's really cool. And the last small note about documentation, unfortunately, not for all your questions the assistant will realize that he needs to use documentation tool. Sometimes it can be a bit tricky to force them to use documentation. That's why the MCP server also contains prompt for that. You can select prompt documentation in UI, fill in your question in the field. For example, how to set up different retention for different tenants, and send it to assistant. And it should use documentation tool to answer, and here is the answer. In the rest of the document here, it also suggests some workarounds without using enterprise, for example, but we'll skip it. The root cause of such problems is that the MCP server cannot influence which tools or resources the AI agent will choose for the query. It can only do so indirectly through the description of tools, but it doesn't work well. And it's likely that the quality of the use of tools will be significantly improved when this change in the specification comes into effect. This specification proposal adds search API for tools and resources in Model Context Protocol, and the MCP server will be able to implement this API. It will take some time to release new specification, implemented in libraries, implemented in clients and servers, but I think it could be really good improvement to quality of assistance answers. That's about features. Now a couple theses about how to improve quality of answers. It will be, oh, sorry, I forgot about one section. It will be very quick. The MCP server also has integration with VictoriaMetrics Cloud. You can create API key in VictoriaMetrics Cloud console, put it into the config of MCP as only parameter instead of instance entry point, instance type, instance bearer token, etc. And in addition to all previous tools, for all your deployments will be activated some extra cloud-specific tools. I don't have time to tell you about it more. Maybe in the next meetups, we'll have some roadmap in Project README. You can find the things like support new query statistics feature, add extra knowledge like answers from public Slack, from public chats, and GitHub issues, etc. Implement multi-instance version of MCP, support some additional APIs, support metrics metadata when it will be implemented, etc. So don't worry, I'm not going to tell you the same about MCP VictoriaLogs. Just a couple words. We also have MCP for VictoriaLogs. You can find all information by the link. Here you can see the list of supported tools. It's just all the READ APIs that VictoriaLogs supports. And I want to end with a couple tips how to improve quality of AI assistant answers. Of course, main thing here is LLM that you use. During all presentation, I was showing you Cloud. It's not an advertisement. They didn't pay me, but for me, it works better than all other LLMs in observability scenarios. Maybe I should test other LLMs more, and I'm gonna do it in the future, but not now. Selection of tools now is responsibility of clients, so it depends on your client how assistant work with MCP. But maybe it should be improved in the future. And of course, a lot of things depends on your wording. The more complex scenario, the more correct wording should be used. Use context. It's really powerful thing. For example, if you want to make some complex query to the database, you can find necessary metrics first, and after that say, hey, how use these metrics to query something. It's maybe again about wording, but in other words, if you know capabilities, tools of MCP server, you can better put your request in the right words without abstract wording. And AI assistants every time have hallucinations, mistake, etc. That's unfortunately part and parcel. So you should take it calmly. It's worth double checking something if you are doing something irreversible or dangerous. It's again about wording. If you give more details, it will work better, help LLM to understand what do you want exactly. If you are working with some popular metrics of popular tools, it will work better than with your own internal metrics, because LLM have internal knowledge. It should get in better when we provide ways to add your metadata to LLM context. Right now, you should just know about it. And maybe it's topic for the next part of presentation, but I think power of MCP will be in synergy. If you cover all your observability stack with MCP, it can be really powerful tool with AI assistants, like combine VictoriaMetrics, MCP VictoriaMetrics, VictoriaLogs, and for example, Kubernetes MCP. Yeah, we have no room to live sessions here, but we have tech talks very soon called Can AI or ML Guide Observability. I don't know what Mark and Matthias prepared for you, but I hope it contains some live sessions here or so. Anyway, I think it will be great. So subscribe and join. Well, more than 200 slides flew by like a flash, and that's probably all I wanted to tell you today. Actually, not, but thanks for listening. I'm ready to answer your question in our public Slack, Telegram, GitHub issues, etc.
Thank you so much. Thank you. Again, that was extremely good for me. Personally, I see this presentation first time and I enjoy it. We have a couple of questions right now. I will present them, and also I have a couple questions from myself. Oh, and some additional notice. I believe this meetup will take more than 2 hours. So please prepare some snacks or anything else. So you with us for a while. So we have a couple of the questions. I cannot present 2 of them. So Yasur asked about how it works with the local LLM models. For example, Llama plus Qwen or Mistral or DeepSeek or something like that.
Yeah, I checked it really little. It in some cases it works great with Qwen 3, but I don't remember parameters of that. I didn't check it a lot. Like I should do it in the future, but now I can't say how it works.
Okay, thank you so much. And the next question, that's like continuing of the previous one, and I can answer them. Join our Slack channel where you can ask all the questions. Alex is there, so that's a good place for communication. And Alex Valel can share this link. Also, feel free to join. I have 2 questions. One is more like statement, and the second is question. Am I understand right that the most simplest way to start trying MCP right now is first have Claude desktop, second VictoriaMetrics installation, and third MCP server? So, am I right?
You are almost right. Honestly, it's not required to have VictoriaMetrics installation because we have public playground, and we have section in our README. Try it without installation, and you can just install Cloud Desktop, and that's it. Configure it, and that's it. Try to use.
Okay, thank you so much. And the next real question, Matthias asked, I cannot find, ask about using several MCPs together. For example, I install VictoriaMetrics MCP and Alert Manager MCP. Is it possible to get combined value from 2 of these tools together?
Of course. It depends, but again, it depends on your client and LLM. It can understand that you should use 2 different tools and combine all data from all response from the tools. and it should work. It definitely works with Cloud.
Okay, thank you. Thank you so much. I personally tried with Cloud Desktop, and I recommend to start with it. That was very simple. And some additional comment from Roman. Roman, hello. It should be a kubecon. I personally agree.
I don't have Shengem either right now, but maybe.
Yeah, we work on that. Okay, thank you so much. Let me remove you from stage.